Hey class, hope you're well. Oh, yep, we are recording. I obviously didn't spend a whole lot of effort on this cover, and I just got done with part one, and I'm going right into part two. And I apologize, but the parrot is getting more antsy, and he's screaming. She's screaming more, and the parakeets are screaming more, and my cockatiel is chirping. So there's a lot of distractions, but that's all right. So whereas last week, or 2 weeks ago, I guess it was, we did part one, which talked about water management and resources and the challenges and solutions to too much water and then too little water. The second part here focuses on water pollution. I am going to, so we cover the challenges. It's the pug, sorry, that my dog is snorting. Oh dear. We talk about the challenges and solutions to water pollution. Now, I probably gave a shout out in lab already to my 7th grade science teacher who, bless his heart, was way before his time. We were young, we were 14, we were jerks because all 14-year-olds are jerks, so we didn't appreciate him and all of his wisdom. But I do appreciate him now, and one thing he would always say was, dilution is not the solution to pollution. That was his big saying, and he's right. Mentioned in the first part of this lecture that water is a universal solvent. It dissolves not everything, but almost everything, which is great in living organisms and in like streams for like dissolved oxygen and dissolved minerals for the animals that live there, but really not cool when it comes to pollution because it dissolves lots of pollutants and carries it everywhere. So we cannot dilute our way out of the pollution problem. We tried that for a really long time. You know, when we would put all the crap from industrial and manufacturing processes into a stream or a river or into the ocean because we figured there's a lot of water there. It'll just dilute and it won't be as harmful. And guess what? We were wrong. Anyway, so let's get on this. Pollution, just like with air pollution, is just anything that is in water that is considered harmful to has a harmful effect on humans and other living things. So there's all kinds of pollution in the water. There's sewage, which is human and medical additives, human sewage, of course, feces, urine, whatever. There's disease-carrying types of water pollutants, industrial and household chemicals, sediments, radioactive pollutants. There's just plain old litter in water. Lots of different types of ways that water becomes polluted and then cannot be used. It could be like physical parts that are added to water, but also you have chemicals that are dissolved in water as well. Now, water that's under the ground gets polluted because we've been digging down into the water table for a very long time, and we've been through different processes. We have actually polluted the water because we have been digging down into the ground for a long time. So it's either because we've dug down that far or because naturally water percolates through the soil and through bedrock to go into aquifers, into groundwater. Water then carries the pollutants with it. Now, naturally, many of these pollutants are filtered out, but there's so much pollution that not all of it can be. And so, therefore, we have managed to pollute the water that is under the earth, too. You have different, to categorize water pollution, there is pollution that comes from direct sources that we can actually pinpoint. These are point source sources of pollution, like right out of like a like a pipe from a factory, for instance, or like, an oil tanker gets a gash in it. That's right from the source. Um, Problematic, but easy to manage because you know where it's coming from. But one of the big challenges with water pollution is we don't always know where it's coming from directly, because it comes from all over, this non-point source pollution, which is, again, most of our problem with pollution, over 70%. So just runoff from large areas, from cities, from agricultural fields, soil erosion, construction sites. And so this is definitely a challenge. So solutions, why not? We're going to jump right into this. You see here on the right-hand side, that's the Cuyahoga River in Ohio that was so polluted because here we went ahead. Dilution. Before we thought, well, we can dilute our way out of this. We thought dilution was a solution to pollution, and no, it is not. Dilution is not the solution to pollution. And look at the Cuyahoga River had so much pollution in it that it actually caught on fire, and not just once, but like I think 3 times. And because before we had our first laws put into place, you could do that. You could dump anything you wanted into these waterways. It was not illegal, believe it or not. So as far as point source pollution, the Clean Water Act in the early 1970s was the first laws put into place to prevent toxins from being dumped into waterways, into rivers. And before then, yeah, it was not a big deal. Raw sewage even, just right into a river. Can't do that anymore. So as far as the solutions, the laws and legislation, absolutely. Just like with air pollution, this was key to getting the ball rolling. Safe Water Drinking Act. This was to monitor the water that we drink back in the early 70s. Before then, there was, believe it or not, there wasn't that put into place. Water Quality Act in the late 80s. This was to help stem the tide of non-point source pollution. And, source point solution, that's the easier challenge, because you know exactly where it's coming from. But since most of the pollution is from non-point sources, this can be challenging. So what do we do? Like storm drain management, for instance, sediment pollution. And you see, like, if you go by a construction site, because a lot of non-point source pollution is just washed off on construction sites. But like you see, like nowadays, like those fences that are put up, or those big, they look like oversized pantyhose filled with straw. They're there to prevent all of that runoff into waterways, away to part of the Clean Water Act, or the Water Quality Act. That way to prevent that from occurring. The Superfund Act, this addresses just any of these toxins put into the environment to keep them from getting into the water. And the litter laws, Resource Conservation and Recovery Act, this was more for like solid waste management, but this helps keep water free from litter. And you see this this terrible litter problem here on what otherwise is a beautiful lake. These litter laws, anti-littering, litter cleanup laws. This is a relatively new, and we're going to see more of this in the next few slides. This big sock that's put over a pipe from city streets. A big net, I should say, not a sock, that removes the litter from that before it goes into a waterway. So these various different laws that are put into place and enforced keep water from becoming polluted. You also have some technology that goes on here, different methods as far as water that does that is polluted, how to clean that up before it's released back into the environment. Your modern municipal sewage treatment plant aids to do that. For if you live in an area where your water comes, where you don't have a septic system, thank you, and drain fields, and your wastewater goes to a municipal sewage treatment plant. Now, what they do in primary treatment, all the water comes to them. We used to tour the Bethlehem wastewater treatment plant. We don't do that anymore, and they go through this. But basically, what's done in primary treatment is all of those really big things are removed. Anything that gets flushed down the toilet or comes off of roadways, like litter, for instance, this is removed, and you then have primary sedimentation take place. Stuff that's smaller sinks to the bottom. That solid stuff is referred to as sludge, and then that is removed. It then goes on, that's not the end, of course. You get all the big chunky gross stuff out, and then get the little gross stuff out. In secondary treatment, it's really pretty interesting because you have kind of a biological system that goes on here. You have different little single-celled microorganisms that are normally found in water, like in stream water, for instance, and lake water. And these little, they call them bugs, but they're not insects. That they're just these single-celled organisms that convert some of these chemical pollutants into inert compounds, which is really pretty cool. And it's an aeration tank in secondary treatment because these single-celled organisms need highly oxygenated water. So they call them, at the wastewater treatment plant, they call them egg beaters. They're these huge open pools of water, and they look like egg beaters that are aerating the water. These single-celled organisms, these protists, are there converting mostly the nitrogenous wastes. Nitrogenous meaning your urine is made up of a lot of nitrogen. A lot of pee gets flushed down the toilet. There you go. But also other wastes as well. More sedimentation takes place in sedimentation tanks, and thus all the fine particles sink to the bottom, and that gets removed. Again, sludge, secondary sludge. And then tertiary treatment is where the water is finally disinfected. It could be with chlorine, it could be with bromine. Sometimes they use UV radiation, UV light, to disinfect water. And then it's discharged into a waterway. It's discharged into a wetland or into a nearby river, like the wastewater treatment plant in Bethlehem. That wastewater is that wastewater treatment plant is right next to the, now I don't remember. Crap. It's either the Lehigh or the Delaware River. Oh my gosh, my brain is faltering. And that water gets released into, after tertiary treatment, gets released into the river next, whatever river runs right by the Bethlehem wastewater treatment plant. It is not treated to drinking water standards. So you can't drink the water right from the wastewater treatment plant after tertiary treatment, but it is safe, quote unquote, safe to release into a waterway. Now, there is in European countries, they have a fourth treatment to remove some hazardous liquid materials, pharmaceuticals, chemicals, and other oils, because these are not removed with the U.S.'s primary, secondary, and tertiary model of treatment in our municipal sewage treatment plants. So this stuff is still there when it's released back into waterways, which is why they implore you not to dump these things down the toilet or in sinks, like all your leftover pills or whatever. Or dumping like oil down a sewer grate, like used, not vegetable oil, but like motor oil, because that's not removed. So that's why these are disposed of in different ways. You shouldn't pour these down the drain. Now in Europe, they have figured out a way to do this, and they are removing these. And these are mostly removed in drinking water plants before it goes back into your house for you to drink. And keep in mind too, before the Clean Water Act in the 70s, that wastewater treatment plants were only primary and secondary. So the disinfection bit did not apply. Now there's a short video you can watch on this. I recommend you do it. It's very interesting and gives you a much clearer view as far as how these treatment plants work. But certainly part of the solution in regards to tackling pollution in water is by cleaning the pollutants out of water before they're released back into the environment. Oh, sorry, these slides are goofy here. Kind of, okay, sorry about that. Now, there is technology involved, just like with removing pollution from air. Air stripping and activated carbon filtration. Activated carbon filtration is that is just like your filter in your fish tank. Activated charcoal removes pollutants from water as it's recycled in your fish tank, and that is done on a large scale to remove the pollutants in water before it's just from like a manufacturing plant or industrial plant before it's released into a waterway. And just like you change the filters in your fish tank, they do the same when they become ineffective. Also in your like your water filters, if you have a water filter pitcher, like a Brita filter on your, either a Brita filter on a pitcher of water that sits in your fridge, or if you have one attached to your faucet, that uses activated charcoal as far as activated carbon for removing pollution from the water that you drink. Air stripping basically kind of does the same thing. It sprays water up in the air, and there's some chemicals in polluted water that are really volatile and they evaporate easily. And so if you just spray water up in the air, it actually will evaporate, which is pretty cool. But then when it's sprayed into the air, it then kind of trickles down over some materials, the packing material, which then continues to remove pollutants from the air as well. So you have that water that chemicals that evaporate, but then get captured by these filtration packing material, and then the water is clean when it comes back or out the other end. Oop. And oh crap! Nope. There we go. You have methods of cleaning up water that include bio and phytoremediation. Now, bioremediation just overall is when you use a living organism to remove contaminants from something else. So to remove, for instance, if you have contaminants in water, you can apply certain microorganisms that will actually break down those chemicals, kind of like in the secondary stages of wastewater treatment in a wastewater treatment plant. You apply these, like some are even bacteria, you apply these, for instance, to hydrocarbons and oil spills, and they break that oil up down into just water and carbon dioxide, using a living organism to break down that pollutant. Now, phytoremediation is bioremediation, but it uses plants. So you can have water that's contaminated, and the plants will uptake those chemicals and remove the plants, and then what you have left over is relatively clean water. Other chemicals, like oxidants, for instance, are used that can convert harmful chemicals into less harmful chemicals. So this is used mostly for underground water systems. This is notoriously difficult to clean up, and often we see more and more that it is a problem with like for instance, like the way that some of these chemicals used to be stored were underground storage tanks, which of course have since rusted through and then contaminated the groundwater beneath, like old gas stations, for instance. And this chemical oxidation is a way of cleaning up that water. And then, of course, personal stewardship um, endeavors. Um, do your best to keep things out of waterways, like don't pour your medications, cleaners, household products down the toilet. There are ways of disposing of those in a safe way. They even have those household hazardous waste collection events um, where you can take these liquids to be disposed of, like paints and solvents and all of that, um, to keep them out of our waterways. It's easy as picking up after your dog. I mean, there are lots of reasons you should clean the poop up after your dog, for crying out loud. Don't be so lazy. I'm not accusing anyone, but, living in a neighborhood, I see it a lot. But it does contribute to water pollution because of after a rain, that the feces can go into waterways. Be a part of the solution. Be part of a litter cleanup project, for instance. We learned about eutrophication in a lab that we did. That is too much nitrogen in waterways causing algal pollution. And part of the solution would be to not use fertilizers on your lawns. And then letting people know about this. And I've probably the fourth time I've mentioned it, but we are fortunate that we live in a region that really doesn't have a problem with water stress from a supply standpoint, but we also have infrastructure in place that, we have access to clean water for the most part. But we're all on the same planet, right? We're all on the same ship. And so educating people about just overall initiatives for conserving water and for keeping water clean, so all of us have access to it, is a critical part of the puzzle. That's why you're here, right? This is why we're learning about these sorts of things. All right, well, that is it for now, and I hope you enjoyed that. I hope you learned a lot from that, and we'll see you again another time. Take care, guys. Bye.